Hey people, welcome back. And in this session, we are going to learn about the basic requirement of performing a hypothesis test. The first and foremost thing when we start hypothesis, you should be clear up what is your data type. Mainly, we will say data either you are dealing with the number, which is the numerical data, or non-numerical data, which is the categorical data. First, you have identified that. So once your data you have identified, and suppose your data is a numerical data, then you will be checking the numerical data is normally distributed or it is non-normally distributed. Normality of the data you have checked. If data is normal or not normal, we'll keep in mind. Rest of the thing that will look for the variability, basically dispersion or the centering. So we may be looking for the centering. Comparison, basically in centering we compare the mean and the median. When you look for the dispersion comparison, in dispersion we mainly deal with the standard deviation or the variance. Major is the standard deviation. So we have the data type, then we have the numerical or non-numerical, which is the data type. And then if it's a numerical, we will see if the data is normally distributed or not normally distributed. And you remember normality, we will look from the Anderson-Darling test. So normality means if the p-value is greater than 0.05, data is called to be normally distributed at 95% confidence level, or p-value is less than or equal to 0.05, then data will be non-normal. Just to define your knowledge back. Now, you have identified data is normal or not normal. You are comparing the mean or maybe the standard deviation or the median. Then we will look for the how many categories you are comparing or what is your sample group or subgroup size. So in this case, you will be looking for, are you comparing maybe target value with some observation or the subgroup or sample group or the data which you have collected. You may be comparing the observation of one group with observation of second group, or maybe you are comparing two or more, maybe three or more than three subgroup with each other. These are the observation groups. And based on that, now once you have identified all your data, now you have to define the hypothesis. Next, when you define the hypothesis, you will be defining the hypothesis. Are you looking for the same or are you looking for the difference? If your hypothesis, what you are defining, which means the observation you have and against the assumption. If assumption and observation data, what you are collecting, there is no difference between these two, then it's a null hypothesis, and we will be deciding based on the p-value when it's 0.05. If your assumption and observation, there are difference or there is difference between these two values, which means they are not same, so then it's a alternate hypothesis and p-value will be less than or equal to 0.05 at 95% confidence level. And then based on this, we take our decision. So you have first statistical decision, which means based on the p-value, if it is greater than 0.05, you will say no difference, they are same. And in case your p-value is less than 0.05 or equal to 0.05, then you will say there is a difference. And based on this, there is difference or there is no difference. You have already defined the hypothesis. So you will take your practical decision sometime, like as you have done the improvement in the process. And you are looking for that before improvement versus the after improvement, there should be difference. You are looking for the improvement, then you are looking for the alternate hypothesis. Maybe you have the first person versus the second person, like as though maybe machine 1 or machine 2, and you are looking for the performance of both the machine, and you are looking for that there is no difference in the machine. So you are comparing here, and if there is no difference, which means p-value is coming greater than 0.05, then you will be saying that there is no difference. So we have to understand first what exactly our hypothesis is, what we are trying to prove. We will be defining that, and according to that, whatever the result will come, we'll take a decision. But in case you are not taking the right decision, suppose actually there is no difference. This means it's a null hypothesis and your p-value is greater than 0.05. But you are taking a decision, or you are calling this as an alternate hypothesis, which means when there is no difference, you are telling there is a difference, then this is your type 1 error or alpha error. This is also called as a false positive, and this is also called as a producer risk. In other case, when you are looking for that there should be difference, like as before and after improvement, you have done some changes in the process and you are looking for that your process should have improved, which means you are looking for p-value should be less than or equal to 0.05. There will be alternate hypothesis, but this alternate hypothesis you are not able to interpret correctly, and you are telling no, this is a null hypothesis. So then this error is called as a type 2 error or beta error. This is also called as a false negative, and this is also called as a consumer risk. So we should be avoiding these risks. We should be avoiding taking the false decision, and we should be taking the correct practical decision based on the hypothesis testing. This is what expected minimum from a Six Sigma professional, that you are able to interpret the right statistics, reading the correctly p-value, and taking the correct practical decision based on the statistical decision. So in the next session, I am going to explain you about how to select the conditional hypothesis test based on the data type, based on the sampling or variation, based on the sample group you are comparing. All right. Thank you so much. I'll see you in the next session.